We're going to demonstrate how to wrap a sensor as a service. So here we're going to use the standard robot we're using. So we just launch Gazebo with the standard launch from Ross. So we're going to see that our robot is ready there, and we're going to inspect what topics. So to do this, we use, well, we can also manipulate it, and here we see the list of topics, and we see the topic odom. That's where this publishes the odometry. This is what we want to subscribe to. So we're going to construct a standard subscriber. To do this, we need to know more information about it, and we found the type here. So ROS types are not extremely well documented, but it's good to go to the web and find the structure for them. So I've done that, and in this web page you can see that it's a very sophisticated nested structure for an odometry message, and it comes in the package nav_msgs. So sometimes it's good also to look for an example of the usage of some message type. So we look here, and there's a sample code of somebody who publishes odometry messages. It tells us actually what is the include required to use these message type. And there's also some examples of its use that we can see here, how we access the different fields in the nested structure that we have. So let's create a package. We go into our workspace, into source, and we use the create package command. We are going to make this package is our odometry service. So we have there our include and our source directories and other things to build it. Let's now copy the sample listener from the beginner's tutorials. This is it. I'm just going to save it into my downloads area, and then into actually the package I created. So if we go into source, we can see this standard listener from beginner's tutorials. We're going to rename it into our odometry service code, and I'm going to delete all the comments to be left just with the structure. Now the first thing is, now we don't listen to strings, so we need to use the include file I mentioned before, because now we're going to listen to odometry messages. So we insert that include here, and we continue cleaning the code here of extra comments so that we just have the basic structure. We're going to test listening to odometry messages. Because of that, this is not going to be a node named listener, but it's going to be a node named odometry service. Clean up more code, and what we see is that we should rename the callback to something more meaningful, like listening to odometry. And this name of the callback is what we're going to use when we subscribe. So when we receive messages on the topic, we'll go there. And remember, our topic is odom. We're wrapping up the topic odometry as a service. Clean up a bit more the code here. And we're going to try to compile listening to this. So for that, this callback needs to be changed. So now we're going to adapt the parameters that arrive to the callback to use or type the odometry message. So it comes from a package, as I mentioned, nav_msgs, and the actual type of the object is odometry. So let's clean this a bit more, and we're gonna see that we can remove the comment and properly name it as a wrapper. We will now try to construct a meaningful callback, so we cannot really return a string. So we can see a bit of how this code is used, what are the actual sub-classes in the object that makes an odometry message. So we see that it's a very nested structure. We're not going to use the quaternion at this stage. We're only going to use the fundamental X and Y positions. So we're going to just log the details of the X, Y, and Z of the message we receive. And that's going to be our callback at the moment, just to confirm we're listening to this topic. So we are ready to inspect our coding and our compiling instructions. That is in CMake list. We're going to use the same mechanism that you see in the beginner's tutorials for building a listener. So the first thing is the executable. So we go to this line and clone it. So we preserve the structure in the comment, but we need to change what is our source file. So that's the name of our source file. So that's what it goes here, and that will create a node with the name of the project. That takes care of compiling the source, but we also need the commands for linking it. So we also clone that. This is such a standard package, we don't need to do anything in particular to how this executable is going to be linked. And the other aspect is any dependencies on other packages or message generation. At the moment we use the standard one, so we are ready now to compile this listener to the odometry. Let's check that we have it there, so we can run it, and there we go. How do we test that it's usually using the odometry properly? Well, we go to our window that allows us to move the robot around. So here's our window with the key controls. We move the robot in different directions, mainly the direction of X, and we see here the robot is going backwards. So we get a negative value. Now it's about -55. Then we move it forwards, and the odometry comes down from -55 almost to 0. Now it's growing from the reference point of the robot. That confirms that we can listen to messages, so we play around a bit, also change the Y value, and we confirm that the odometry of the robot is being read by our code. Now we're going to turn this also into a service. So for that we need to create the directory SRB, where we're going to define how logic label finite state machines are going to consult the odometry. So this is going to be a very simple service, a service that returns positions in X and Y. So we create a file that does not require any inputs, and everything before the dashes is the outputs. So we now gonna modify our code to add to it a function that makes it a service. So let's go back to the example of a service in the beginner's tutorials. That was the code to add two numbers. So this is the callback to add two numbers. We're gonna insert it here in our code and clean it up a bit, so it has the same structure for us to becoming a server, but instead of adding, we need to do something different. Let's advertise that we have this capacity. So we're going to advertise that we are an odometry service, and we indicate that we're ready, and we're going to change the name of the callback The name of the callback now is going to be to return the XY in centimeters. So because this is a new callback, in our advertise statement, we change which function is the callback when we are requested this service. We also gonna have two integer variables that now that we can read the odometry, in the function that we read the odometry, we update those values. So we have a record of the best odometry we know, and we need to include the file for our service because that's going to be generated, but that's going to describe what our service is. So the parameters of the callback for the service have to change. This is our package, and the name of the type is the name of the file we chose. Remember, we chose XY position as the name of our file for services. We can double check that. Remember, in our directory SRV, that's what we just created. So that is how we structure the request and the response. Now remember that we don't need a request, we only build a response. So we're going to clean this up, respond with the value of our local variables for the response for X and the response for Y. And for debugging purposes, we also have a logger statement. Let's clean up this, and we have a callback to work as a server. So we are advertising this function, and this function will grab the most recent values that we have and return them as a response of our service. So we are ready to compile now, but we need to improve the fact that now we do generate messages, so we have to add message generation. This is the same as in the beginners tutorials where they describe to you how to do a service. So you see here that there are several ways to indicate message generation. The most recent of them is to indicate that we depend on message generation. We need to add our file, so we actually generate the corresponding stubs for C++ for this class. We also indicate that we want to generate the standard messages, and we also need to edit the package XML file because we need to indicate the dependencies first in the build environment that we now depend on message generation. So I'm just copying the comment and putting it back in here, more or less where it goes. The order doesn't matter much, but for cleanliness, I also indicate that at execution we need runtime message support. So we are ready to compile again, and now messages will be generated. I could probably show you in the video where this goes, but at the moment I got an error, and this error takes me back to my code. Oh well, I actually had a broken line there, so we can compile again. There's the compiling and the linking. So we need now to run our program. So again, we have our robot ready to move around. This is the window that allows us to play with it, going to the left, to the right, back and forward using the arrows. I didn't even stop that from last time. So now we run the code. Remember, this is going to listen to the odometry and be ready for calls to our new created service. So let's try to see if it's advertised. We see here that an odometry service has been advertised. So we can use the tools to call it, although typically this will be called from a logic label final state machine. We're seeing what information that we can inspect about it, and it doesn't need any arguments. It returns an XY position of our type, so we can actually call it, and we get odometry in X and Y in the frame of reference of the robot. If we move the robot a bit around, it was stationary while I was doing this, so it wouldn't bump into things. And we move it around and spin around a bit. Alright, and we read the odometry again, we get different values. So this allows you to build logic label finite state machines that can consult the odometry.